let's do some more volume practice right here. I'm on page 19. You're going to have to read and get into these situations. All right, they're very doable. This is one about landscaping your yard. If you've ever added topsoil to your yard or seen that happen, or even to a small space, they're doing an entire yard 70 feet by 60 feet. She plans to put down a 4-inch layer of topsoil. She can buy a bag of topsoil for $2.50. And in each bag, that means per 3 cubic feet. So each bag has 3 cubic feet. So she may be buying a lot of bags. And that's what we're going to find out. To figure out the cost, we need to know how many bags it's going to take to cover 4 inches on top of that. So if you think about it, if her yard is more like a rectangular prism. So to draw a little visual right here of what's happening right here, this will totally not be to scale, but I've got a yard, okay, that's basically 4 inches deep of topsoil, and it's 70 by 60 feet. Now we are going to have to do some conversions right here, and I'm not going to do this whole problem for you, but I've got you started. So you're going to need to convert these to either inches or feet. Actually, since the bag is per cubic foot, I would convert that to cubic feet, and I'll help you with that because we know that there are 4 inches, or there are 12 inches in a foot. So this would be 4/12 of a foot, or it'd be 1/3 of a foot. That probably makes more sense. 1/3 of a foot as opposed to 60 feet and 70 feet. Now, if I can find volume, I think you can do it from there. But there's a little bit there on conversions. We have to be on the lookout for those. This one's very similar. A dump truck, they're always doing a cost of gravel or dirt or whatever it is, if you ever got any of that delivered to your house. The truck is loaded with gravel. Average cost. These are pretty basic problems. You probably don't even know what a water bed is, but we used to, a long time ago, it was very popular to own a water bed were basically shaped like this, and you would lay on there full of water. They could get super heavy. They actually caused some problems on some second floor apartments or whatever, and things crashed down. Anyway, there's a bunch of crazy stories about really over heavy water beds. Anyway, water's heavy. So you're going to figure out how much that water bed weighs, because this is what water weighs per cubic foot. And when you get into these problems, you need to be on the lookout for questions that say something like this right here, per cubic foot, because when we get to the test, you're not necessarily going to know this is a volume question. I know you do right now because that's the section we're working on. But you need to pay attention to these little key words right there, because that's a little reminder, oh, this is a volume problem. It's telling you what to do, but it's telling you not so many words, okay? So you're going to have to clue into cubic feet is a measurement of volume, all right? Let's do the one with steel right here. This is a pretty good one. The steel I-beams are very strong. They can support tons of weight. Steel is still expensive and heavy. This steel weighs about 0.28 pounds per cubic inch. Okay, it doesn't sound like very much, but it really adds up. Find the weight of the steel I-beam. Assume all angles are right angles. Notice it's 25 feet. So this is just a cross section. So these are in inches, and this is in feet. All right. So I need to find out how much steel is in this thing. I know this isn't a perfect cross section drawing of this, but it's kind of blown up a little. So I'm going to do a rectangular prism right up here on this top one. I'm going to do 0.5. So I'm thinking length times width times height, because I can do that on a rectangular prism. This right here is 10. That's inches. And then this is 25 feet, which equals how many inches? I need to convert that to inches because my scale is in inches. So 25 times 12 is 300. So this is 300 inches long. So 25 feet, we're talking like the length across a classroom. Okay. So I'm going to do times 300. So that'll do that. Length times width times height. And then I'm going to have another one like this on the bottom. So I've got this one and this one. Those two rectangular prisms are the same, 0.5 by 10 by 300. So I'm going to go ahead and say that all of that is times 2. All right. And then I'm also going to have to add in this rectangular prism inside here, which would be 0.5 times 8 times 300. Okay, so if I add all that total volume together, add those two together, my total volume would be 4,200 cubic inches. Oh, there's my answer down there. Yeah, 4,200 cubic inches. So I can do that times this because it's per cubic inch. So steel weighs this much per cubic inch. So I'm going to multiply that by 0.281, 0.2831. And there's where I would get that my I-beam weighs this many pounds. So now we jumped up there immediately. A long I-beam, it's heavy. That's why you see cranes all the time lifting these things when they're lifting steel and setting it in place. It's 1,189 pound beam. Can't necessarily lift that by hand all day, every day. All right. One other deal right here: find the edge of a cube. So one thing you're going to have to learn how to do is, and this may be foreign to you, the volume of a cube. Well, a cube is length times width times height. In a cube, they're all the same. So what happens is it's x to the third power equals this. This you probably don't know how to do. Okay, how do you undo cubed? I know, so you're thinking like square root, but it's not square root. So there's a math button on here. Go to math and you'll go down to number 4 and you'll see it's a cubed root. Okay, and you can type this in Google. The cubed root, there's the little 3 that's up there, of 4913 is 17. It's a perfect one. I chose that on purpose. So what that means is 17 times 17 gives you this 4913.